काम क्रोध और लोभ मोह बिंस जाए अहमेव। नानक प्रभ शरणागति कर प्रसाद गुरुदेव। O God, I have come to your shelter. Please do this favor to me that all my lust, anger, greed, attachment, and ego may vanish. Unit 2 Atomic Structure Part 2 by Amrik Singh, PGT Chemistry. Development leading to Bohr's model of atom. First one is dual character of electromagnetic radiation. Second one is experimental result regarding atomic spectra, which can be explained only by assuming quantized electronic energy level in atoms. Wave nature of electromagnetic radiation or electromagnetic wave theory. James Maxwell in 1870 suggested that when electrically charged particles move under acceleration, alternating electric and magnetic fields are produced and transmitted. The main points of electromagnetic wave theory are: first point is the oscillating electric and magnetic fields produced by oscillating charged particles are perpendicular to each other and both are perpendicular to the direction of propagation of wave as shown in the diagram. We have three axes. In one axis there is magnetic field, in other axis in red it is electric field, in blue it is magnetic field, and in other direction there is the direction of propagation of wave as clearly visible in the diagram. And the main summarization is that in this theory, whenever a charged particle moves under acceleration, okay, electric and magnetic fields are associated with it, which are perpendicular to each other as well as to the direction of the propagation of the wave. Second point of this theory is, unlike sound wave or water waves, electromagnetic waves do not require medium and can move in vacuum. Okay, electromagnetic wave don't require any medium. They can move even in vacuum. There are many types of electromagnetic radiations which differ from one another in wavelength or frequency. These constitute what is called electromagnetic spectrum. There are many types of electromagnetic radiation. We know these may be visible, IR, ultraviolet, cosmic, microwave, sound waves, all the type of electromagnetic radiations. The frequency mu, wavelength lambda, and velocity of light c are related by the equation c is equal to mu lambda. Point number 5. In vacuum, all types of electromagnetic radiations, regardless of wavelength, travel at the same speed, that is 3 into 10 raised to power 8 meter per second. That is the with velocity of light. Note, we should know have some basic knowledge about the waves. Now, wavelength of a wave is defined as the distance between any two consecutive crests or trough. It is represented by lambda. Let us see the diagram. In diagram it is shown that the upper portion is crest and the lower portion is trough, and the distance between any two consecutive crests and troughs as shown in diagram is known as lambda. It is known as the wavelength. Frequency of wave is defined as the number of waves passing through a point in 1 second. In 1 second, how many waves are passing through a point? That is its frequency. It is represented by mu. Amplitude of wave is the height of crust or depth of the trough. It is represented as A, as shown in the diagram. Amplitude is shown. Height, it is height of crust or depth of the trough. Wave number is the number of wave present in 1 centimeter length. It is equal to reciprocal of wavelength. It is denoted by wave number is mu bar, that is equal to 1 upon lambda. Velocity of wave is defined as the linear distance traveled by wave in 1 second. Then therefore velocity is linear distance traveled by the wave in 1 second. Limitation of electromagnetic wave theory. It explained the phenomena such as interference, diffraction, etc. But it could not explain the following phenomena of black body radiation, photoelectric effect, variation of heat capacity of solid as a function of temperature, line spectra of atoms with reference to hydrogen. Particle nature of electromagnetic radiation or Planck's quantum theory. Point number one, main point of this theory, Planck suggested that atoms and molecules could emit or absorb energy only in a discrete quantity and not in a continuous manner. Everything is going on in discrete quantity, small packets, not the continuous one. Planck gave the name quantum to the smallest quantity of energy. The smallest quantity of energy was named by Planck as quantum, that can be emitted or absorbed in the form of electromagnetic radiation. Smallest packet is quantum. Point number third, the energy E of quantum of radiation is proportional to its frequency and is expressed by the equation E is equal to h nu. But nu is equal to c upon lambda. Therefore, the equation will become E is equal to h c upon lambda, and E is inversely proportional to lambda. The proportionality constant h is known as the Planck's constant. Its value is 6.6 into 10 raised to power minus 34 joule second. The total amount of energy emitted or absorbed by a body will be some whole number multiple of quanta, that is E is equal to nh nu. N may be 1, 2, 3, 4, 5 and so on. Photoelectric effect. In 1887, H. Hertz performed a very interesting experiment in which electrons were ejected when certain metal, example potassium, rubidium, cesium, this group 1 element, etc., were exposed to beam of a light. This phenomenon of ejection of electrons from the surface of a metal when beam of a light of suitable frequency fall on it is called photoelectric effect. The experimental setup is shown in the next slide. Hanji, we have this experimental setup. We are seeing the vacuum chamber is there, as clear in the diagram. Metal surface is there, detector is there, emitter and battery is also there. Photon of light striking on the metal surface, and nothing happens when light is not falling on the metal surface, and emitter shows no current as long as we are seeing light, photon of light strikes on the metal surface. Electrons are ejected as shown. They move toward the positive electrode, that is anode, because it's a positive, and attract the photon, the electrons, having negative charge, and the current is shown by the emitter. Let's see again, once again, the photon is striking metal surface, electron is ejected and it moves toward the anode, and emitter shows the formation of current. In this way is the experimental proof for photoelectric effect. The result observed in this experiment were: first one, the electrons are ejected from the metal surface as soon as the beam of light strikes the surface, and there is no time lag between the striking light beam and the ejected electron from the metal surface. Second result was the number of ejected electrons is proportional to the intensity of light. Third point, for each metal there is a characteristic minimum frequency mu naught, also known as the threshold frequency below which photoelectric effect is not observed. At a frequency mu greater than mu naught, the ejected electron come out with certain kinetic energy. The kinetic energy of the point number 4, the kinetic energy of the ejected electron increase with the increase of frequency of the light used. All the above result could not be explained on the basis of law of classical physics. Okay, no, we should know the difference between the intensity and frequency. Suppose I have the white light, I have the bulb of light, I have bulb of 10 watt, I have a bulb of white light, I have 10-watt bulb, I have 20-watt bulb. I am just increasing the watts, that is the number of electron ejected, number of electron emitted are increasing as the number of watts are increasing. As the number of watts are increasing, the intensity is just increasing. There is no change on the frequency is same, white light. But as long as I changes the frequency is changing, then it's have no effect of watt, whether it's maybe 10 watt, 20 watt frequency. If I'm changing from white to blue, frequency is changed, have higher energy. Okay, we should know the difference between frequency and intensity. ठीक है, frequency I am changing the wavelength, intensity means I am changing just watt, number of emitted photons, electrons, okay, from the source. Explanation: Einstein 1905 was able to explain the photoelectric effect using Planck's quantum theory of electromagnetic radiation as a starting point. Shining a beam of light onto a metal surface can be viewed as shooting a beam of particles, the photons. When a photon of sufficient energy strikes an electron in the atom of the metal, it transfers its energy instantaneously to the electron during the collision, and electron is ejected without any time lag or delay. Okay, greater the energy possessed by the photon, greater will be the energy transfer to the electron and greater the kinetic energy of ejected electron. Since the striking photon has energy equal to h mu and minimum energy required to eject the electron is h mu naught, also called work function W naught, then the difference in energy h mu naught is transferred as the kinetic energy of the electron. Following the conservation of energy principle, the kinetic energy of ejected electron is given by h mu is equal to h mu naught plus half mv square, where m is the mass of electron, v is the velocity associated with the ejected electron. Point number 5. Lastly, a more intense beam of light consists of large number of photons. You know what is mean by intensity? Large number of photons. Consequently, the number of electron ejected is also larger as compared to that an experiment in which beam of weaker intensity of light was employed. Okay, thanks for watching my lecture. Be at home, be safe. Thank you again.